reactance can be defined as the process of limiting or opposing the flow of current within an AC circuit using capacitors and inductors. The greater the component's reactance, the smaller the current will be. There are mainly two kinds of reactance, capacitive and inductive. Inductive reactance is simply the reactance produced by inductors, denoted by XL. Inductors store energy temporarily as magnetic fields and coils. When an alternating current passes through a circuit, a changing magnetic field is created. The change in the field induces another secondary current within the same circuit, and via Lenz's law, the direction of this current opposes that of the main current. Hence, the inductive reactance opposes the change in current through the element. Due to this, the current flow delays and creates a phase difference between the current and voltage waveforms, which causes the current to lag behind the voltage. Similarly, capacitive reactance is the reactance produced by capacitors, denoted by Xc. Capacitors temporarily store energy via electric fields in conducting plates. In AC circuits, the applied voltage continually changes between positive and negative polarities. Due to this, the capacitor alternates between charging and discharging, with the current flowing through it being restricted by the internal impedance of the capacitor. This in turn creates a phase difference between both waveforms, causing the current in this case to lead the voltage. Now let's look at some examples. In the first example, we are asked to find the capacitive reactance of a conducting plate for a 5 kHz power supply. To solve this problem, we simply apply the Xc formula shown earlier, giving us a value of 4.55 ohms. In the second example, we are asked to draw the waveform of the voltage counterpart to an inductive current equation. To solve this, we first use Ohm's law to convert the current to voltage. We then shift our voltage waveform by 90 degrees, since current lags behind voltage in inductive reactance. Plotting both equations gives us a graph which looks like this.